Okay, so real quick, let's take a look at the calendar. So we're sitting, let's see, we're on Friday. That's nice. Really good. What a nice surprise. We're going to cover 5.5 and 5.6 on Monday and Tuesday. And then remember, we started the project on Wednesday. Looked like most of you were done or mostly done. Remember, you want to present it well, make sure the work is clear, easily followed. Do a good job presenting your final project when you turn it in. I only want one from each group. I think everybody was in a group, so we're in good shape there. And then if that's one you want to upload to your ePortfolio, make sure you stop by the office, or if you've got a scanner at home. It's really nice if it's one PDF document rather than, if you scan at home and it separates them, that's not quite as good. So if you're not sure what yours does, the office does a great job. Yeah.
Just wondering, so we only have to put on one project on ePortfolio?
You only have to, right, only one on the ePortfolio, and I only need one handed in per group. Okay? If you want to put them all on there and do a good job on all of them, that would be even more impressive. Okay? All right. And then again, a word about the ePortfolio. There are lots of people in here that have done them. They have trainings over at the Health Sciences Library. You need to have that done after we come back after fall break. So we're sitting right here. Next week we've got a full week of school. The following week is a 4-day week. That's parent-teacher conferences. By the way, make sure you get signed up for those if you haven't already. Okay? The next week we have a 3-day week. We've got 2 days for fall break, and then we come back. That's when I'm going to check your ePortfolio. So you should have it linked to your MyPage account. I should be able to log into my MyPage account, pull up my class roster, and it'll have a little link where I can go directly to your ePortfolio. Okay? I don't have to ask you or you email the link to me or anything like that.
With the parent-teacher conference, do we go to our Class Connect teacher? Or
Connect.
Okay.
Connect. Yeah, it's by Connect.
Okay.
Yeah.
So it should do that automatically, the ePortfolio?
You have to set up a link, but they have instructions on how to do that. It's a really easy process.
It's like on the side.
What's that?
It's on the side of my page.
Yeah.
Your student thing, and you just put in, I think, your email address.
So Ingrid knows exactly how to do it. It's pretty easy. Okay? Anything else? Okay. So don't get too distracted by these days off here. Let's focus. We do have an exam coming up a week from Tuesday. Let's make sure we're all ready for that. Okay. So these should be really familiar questions. I'm sure you've seen this stuff before. You probably started this when you were in pre-algebra or algebra at some point when you were in middle school. So we want to find two numbers that multiply to be 12 that combine to be 7. 3 and 4. Piece of cake, right? Multiply to be 15 combined to be negative 8. Negative 3 and negative 5. Or negative 5 and negative 3. Now those two are pretty easy. They do get a little bit more complicated. Multiply to be negative 20 combined to be negative 1.
Negative 5, 4.
Okay, negative 5 and positive 4. Could you reverse that order? Yeah. You couldn't. You'd need to have a negative 5 and a positive 4. Now you could do 4 first and then negative 5, but the 5 has to be the negative because the one that they combine to be, the one they add up to be, is negative. So you need the bigger one to be negative. Multiply to be negative 40 combined to be negative 39. Okay. I heard a negative 1 and a 40. Is that right?
No.
Okay, these would multiply to be the correct number, but they'd add to be a positive rather than a negative. So I need the 1 to be positive and the 40 to be negative. Again, if they're combining to be a negative, you're going to need the bigger one to be a negative. Okay? All right. Polynomials that have 3 terms are called, this is a tough one, trinomials. So, if it's got 2 terms, we call it a binomial. 3 terms, it's a trinomial. What was one term again? I mentioned it the other day. We don't say this very often. We call it a monomial. Okay? All right. And it's very useful to write polynomials as multiplication problems. So write them as factored polynomials. Now, there are 2 different categories, in my opinion, of trinomials. Okay? This is not mathematically precise. This is just the way I like to explain things to help people understand what's going on here. When you've got a trinomial, you've got an easy type of trinomial or a hard type of trinomial. Okay? And the way you tell an easy one is it starts off with a perfect square with a coefficient of 1. So a perfect square of whatever the variable happens to be, if it's x, if it's m, if it's t, whatever it is. So a 1x squared, a 1t squared, or so forth. Okay, if that's the case, then it's pretty easy. It's as easy as answering these questions that we had up here. Now, if the numbers get big, then it can be a little harder than the numbers here, okay, but still pretty easy. If it has a number other than 1, if it has a 2, a 5, a 15, a 12, a 6, a negative 17, if it's got a number like that, it's a bit more complicated, so we'll just lump those together and we'll call those a hard trinomial, okay? So if it's got a coefficient of 1, it's going to be pretty easy. If it's got something other than 1, it's going to be more difficult, okay? So what type is this?
Easy.
That's an easy one, okay? If it's easy, here's why it's easy. Because all you have to do is write down a set of parentheses. Remember that the first two are going to multiply to be this guy right here. So they're going to multiply to be x squared. So I need a term here and a term here that multiply to be x squared. The only way to make that happen is going to be x and x. And then these numbers right here, I need to fill those in. These have to be numbers that multiply to be the last one and combine to be the middle coefficient. So they need to multiply to be 20 and combine to be 9. I need numbers that multiply to be 20 and combine to be 9. 4 and 5, both of them positive, right? Now, if your neighbor, if you look next door, if your neighbor wrote this instead, is that okay? It is. We talked about this the other day because of the commutative property of multiplication. Either one of those would be fine, okay? Now, this is a bit more difficult. Now, I say down below, if you've been reading ahead, most of you have been taught all this material before. You've seen this. If you're really good at factoring, you don't have to use this technique, okay? I like to call this technique trinomial grouping. Some people call it reverse FOIL. There are lots of different names for it, okay? We basically are reversing that process, but we're turning it into the same question. So here's how this works. Again, the first rule in factoring is always take out the greatest common factor. Do these have anything in common? They don't, right? So we can't take out a greatest common factor, so here's what we do. I take this number and this number along with their signs. So this is a positive 6 and a positive 12. I multiply those together and then I get a 72. And then I focus my attention on the 72 and the 17. And I ask myself that same familiar question. What numbers multiply to be 72 and combine to be 17? Are there any numbers that do that? 8 and 9, right? Now, I'm going to write down the 8 and 9 right here. And I'm going to think for a second. Because if you get this step right, the rest of it is rather easy. You're going to get the right factoring. It's not going to be that difficult. So, do these multiply? Positive 8, positive 9. Do they multiply to be positive 72? Do they combine to be positive 17? Okay, if you follow the rest of the problem out correctly, this is going to be pretty easy. So here's what we do. This is why I call this trinomial grouping. We normally group 4 or more terms. We're going to make 4 terms out of this. So I'm going to rewrite the 6x squared. I'm going to rewrite 17x using these two numbers. So I'm going to write positive 8x, I'm going to write positive 9x, and I'm going to write plus 12. So you'll notice that all I did here was rewrite the middle term. The 6x squared was there to begin with, the 12 was there to begin with. I'm just rewriting it as 8x plus 9x rather than 17x. Any questions? Okay. If you have 4 terms, going back to what we learned yesterday, how do you factor 4 terms? You group them. So I'm going to look at these two and these two. So what do the first two have in common? They have an x and a 2. So you can take out a 2x. What's left of 6x squared if I take out a 2x? 3x. What's left of 8x if I take out a 2x? A 4, a positive 4. Okay, now I'm going to focus my attention on these second two. What do they have in common? They have a positive 3 in common. So remember, write down the sign that you take out. So it looks like we've got terms here. If I take out a 3 out of a 9x, I'm left with a 3x. If I take a 3 out of a 12, I'm left with a positive 4. So now I have 2 terms. Do they have anything in common? They both have a 3x plus 4. So I write that down, start a set of parentheses, and I write down what's left. What's left of the first one? 2x. And what's left of the second one? Positive 3. Okay? We're done. Now, that took probably 3 minutes to go through an explanation of how to do that process. I'm sure there are people in here that could have done that using guess and check. Just thought, gosh, I need numbers that multiply to be 6x here and here, multiply to be 12 here and here. This is a pretty easy one. You could probably get it on your first or maybe second guess. But what if you didn't get it on your first and second guess? What if it took you 6 guesses to see whether or not you got it right? Or what if it's impossible to do? The cool thing about this method is it works the same way every single time, no matter how easy or difficult. You may have to grab a calculator, but the process is the same. And if it's prime, you'll know that immediately also. Okay? So if you're really good at factoring, don't write this off and say, hey, this is just for people who don't understand this very well. It's not. Okay? If I have to factor something that even looks moderately hard, I like using this because I can tell immediately whether or not it factors and immediately whether or not it's prime. Okay, any questions? Sure? Really, no one has a question? Most of the time somebody says, hey, what if I wrote the 9x here and the 8x over here? You get the same answer. It's just that these end up in different orders, and does that matter? Doesn't at all. Yeah, Tyler.
But if you change the 3x with the 2x, does that change the answer?
Tell you what, let's go ahead and do this one. If I were to write this in the other order, so if I were to write 6x squared plus 9x plus 8x plus 12, what can I take out of these two guys here? 3x. You're left with a 2x plus 3, right? What can I take out of 8x and 12? 4. Take out a 4. I'm left with a 2x plus a 3, so I take out a 2x plus a 3, and I'm left with 3x from the first one, and I'm left with a 4 from the second one. So, same factors, just in opposite orders. Okay, commutative property again. Okay, good? Okay, let's come down here and take another look at what we've got so far. So, again, if it's easy, piece of cake. It's just a problem that we're real familiar with. If it's the hard type, this is what you do again. Multiply the leading coefficient with the constant terms. So that's where we multiplied the 6 and the 12 together, okay, including the signs. Find two numbers that multiply to be the number in step number 1, so that was the 72, and combine to be the middle coefficients, so that was the 17. Rewrite the middle terms using the two numbers, so that's where we wrote the 8x and the 9x. Okay? You've got a 4-term polynomial, so factor by grouping, what we practiced yesterday. Okay, seems like a lot of stuff to do, but it's really not that bad, is it? Okay, all right. Couple quick things to take note of. Always double check and make sure you got the right number in step 1. Okay, or actually step, what's that? Oh, step 2, right here. Okay, so make sure these are the right numbers. If you mess that up, you're going to get it wrong. Okay, there's no amount of a correct method that's going to improve your wrong numbers that you're putting in. Okay. The other nice thing is, if there aren't any numbers that, so let's see, so I should have done this. If you know there are no numbers that work for step number 2, then what type of polynomial is it? Prime. I've got a typo I need to fix, don't I? It's a prime polynomial. Prime means it doesn't factor, right? And then again, that note that I put, if you're really good at factoring, you can do even the hard ones using guess and check. But you got to make sure you factor correctly and always factor completely, because that's always our last rule. So what we've added today are just a couple of techniques here to work with trinomials. So always take out the greatest common factor. That is the first rule in factoring. First rule is to take out the greatest common factor. Last rule is to make sure you factor completely. If it's got 3 terms, we're going to use these techniques that we're talking about today. If it's got more than 3 terms, if there are 4 or more, then we're going to use grouping. So let's take a look at these two problems down here. Both of these are, gosh, not just easy. These are a piece of cake, right? X here, numbers that multiply to be 12 combine to be 7. 3 and 4. Positive 3, positive 4. You could write those in the opposite order if you wanted, because they're both positive when you've got that commutative property there. On this one right here, the variable is t. The way we're going to make a t squared is to have t and t. We're looking for two numbers that multiply to be positive 15 and combined to be negative 8. Multiply to be positive 15, combined to be negative 8, and that would be negative 5 and negative 3. Aren't those the answers to our question up above? Our starter question? Yep, they are. Okay.
Question.
Yeah.
So it doesn't matter which way you flip the negatives as long as they're both.
So if I write t minus 3 and t plus 3, or sorry,
Yeah, minus.
t minus 5?
Yeah.
Yeah, that wouldn't matter at all. Because we're taking this entire factor and exchanging places with that entire factor. Yeah.
So what if one was positive? So like say t plus 3, it doesn't have to be in a certain order.
Say that was the answer?
Yeah.
Okay, so everybody watch this. I'm changing this problem. Let's say the answer was t plus 3 and t minus 5. Could I write this? T plus 5, t minus 3. The answer to that is no. Because they'd multiply to be negative 15, but what would they combine to be now? Positive 2. Okay? So completely different problem. All right? Doesn't work that way. Any questions? Okay, flip it over. First rule in factoring, greatest common factor. This doesn't have a 1 in front of it, but if we could take a 3 out of everything, we could make it a 1 and therefore make it an easy trinomial. So if we take out the 3, I'm left with a p squared, a minus 3p, and this would be minus 40. Okay, now we focus our attention on this. We're going to ignore the 3 for the time being. Gosh, that's an easy one. The only way to make a p squared is going to be a p and a p. I need two numbers that multiply to be negative 40 that combine to be negative 3. So let's think about this for just a second. Are there any numbers that multiply to be negative 40 that will combine to be negative 3? Okay, 5 and 8, they have a difference. Whoops, they have a difference of 3. Which one needs to be negative? 8 needs to be negative. That will make the middle one, that's the sum of the two of those, that will make it negative. So I'm going to circle this, and that's the answer. I hear some no's. Thank you very much. What is the last rule in factoring?
Make sure you include all the terms.
Factor completely and make sure you include all the terms. You don't want to forget that 3. That was part of the original problem. Getting really good at that today. Okay, there's the answer. If this were a problem on the test, this is the work that you'd want to show. You'd want to circle that entire thing. If I didn't include the 3, you're only producing this highlighted polynomial, not the whole thing to begin with. Okay? Any questions there? Greatest common factor is x. I'm left with an x squared plus a 2x minus, that's still a minus 63. Easy type of trinomial if it will factor further. I'm looking for two numbers that multiply to be negative 63 that combine to be positive 2. Multiply to be negative 63, combine to be positive 2.
9 and 8.
Okay? So, if we can't think of anything, I realize you can, let's just run through numbers that would multiply to be 63. 1 and 63 would. Does 2 go in there?
No.
3, 4, 5, 6, 7 is the next one that will go in there, and how many times does it go? 9. Now, oh, 3 does. 3 does, thank you. 3 and 21. Okay, I'm getting ahead of myself. But can you make a 2 out of a 3 and a 21?
No.
You can't. Okay, so we'll skip ahead. I guess I was just getting anxious. 7 and 9, they need to multiply to be a negative and combine to be a positive. Smaller one needs to be negative, so we're going to have a negative 7 and a positive 9. We'd circle that. Okay, are there any questions?
One question.
Yeah.
So does it matter if you switch to x minus 7 and x plus 9?
Nope.
Okay.
Nope, doesn't. Again, commutative property there. Okay, good. We'll look at the next one. Easy type. Didn't have any common factors we could take out. We're looking for numbers that multiply to be 13 and combine to be 12. So we think about that for just a second. 13 and 12, that looks pretty promising, right? Can you come up with numbers that multiply to be positive, and I like saying the sign, multiply to be positive 13 that combine to be positive 12? The answer to that is no, because here are your only choices. 1 and 13 and negative 1 and negative 13. No, there are no numbers that multiply to be positive 13 and combine to be positive 12. So, the nice thing about that question is if you can't answer it, whether it's an easy type or a hard type, guess what the answer is here? It is prime. Good? Okay, now take a look at the next one. You'll have some problems like this on your homework assignment. For some reason, these tend to freak people out. They'll look at this and think, oh my gosh, that looks easy, but how on earth do I do this right here? Let's ignore the z's for just a second. Let's pretend like they're not even there. So, I'd have a y here and a y here. I need numbers that multiply to be 16 and combine to be 8. Multiply to be positive 16, combine to be positive 8. What would do that? 4 and 4. Both of them would need to be positive. Now, if I come back here and recognize, I need this to be a 16z squared, not just the 16 that it would be here. So if they both had a z on them, would that make this a 16z squared? It would. And when I multiply those middle terms, I'd get 4yz plus 4yz. Does that make my middle term 8yz? It does. So these really aren't that bad. Any questions? Okay. Common factors? Nope. So this is a more difficult type of trinomial. Now, if you want to do guess and check, that's totally fine. I'm going to do it using this grouping method. So I'm going to take the 6 and the positive 10. I'm going to multiply those together. I get 60. I'm looking for two numbers that multiply to be 60. Don't say anything out loud. Multiply to be positive 60 that combine to be negative 19. Multiply to be positive 60, combine to be negative 19. Well, if we just start writing numbers down, even if you had to use a calculator, can I make a 19 out of any of those? But that one's getting close. Next on my list would be 4 would go in there 15 times. Can I make a 19 out of those? Now, I need to make a negative 19, and they need to multiply to be a positive. So we suspect that these are both negative, right? Do they multiply to be a positive? And do they combine to be negative 19? Yes, they do. So we're going to rewrite this as 6x squared minus 4x minus 15x plus 10. Can I erase this list? Okay. I've got a 2x in common here. I'm left with a 3x minus a 2. I can take out, what do I take out here? Take out the sign. Leading sign is negative, so I'm going to take out a negative 5. I'm left with a 3x minus 2. So they both have a 3x minus 2, and then I write down what's left, a 2x minus 5, and there's the answer. Any questions? Okay, now just a quick word. The ones that we've done so far, I mean, if you had to guess what numbers you'd use to make a 6, you'd probably guess 2 and 3. If you had to guess what makes a 10, you'd probably guess 2 and 5. But if they're not those common factors, the ones that we typically use to make those numbers, the factoring problem gets much, much more difficult to guess what the answer is. Okay? In fact, if you have numbers like 6 and 20 and stuff like that, you might have 6, maybe 8 different ways you could check and see what it is. And if it's the last one on your list, you've gone through and guessed and checked 7 times before you get the right answer. Okay? Yeah.
I just noticed some similarities in the first lessons. You know, if you did guess with it though, if you did 3x and 2x out of 6x squared, then you did negative 2 minus
What are you saying?
It's just like a simplified way of looking at it.
What? No, say it again.
I mean, because I can see that 3x times 2x, you're going to get 6x squared. But then also with the plus 10x, you can only be different because you have 2 times 5 or negative 2 times 5. It's just different.
Okay. All right. As long as it works. There are lots of different ways to factor or think about factoring. I don't care as long as you get it right. There are probably a dozen factoring problems on the test. I'd love it if you all got every one of them right. Okay. This has a star by it. What's wrong with this? Okay. They will do that occasionally, or they'll give you a problem and you've got to put it in the right order. So we're going to do 18x squared minus 6x minus 24. And then again, we just apply the factoring rule. So take out the greatest common factor. This one has a 6. We're left with a 3x squared, a minus 2x, and this is going to be a minus 4.
No. It's just regular X.
It is just regular x. Okay? If you make one silly little mistake, either rewriting or in calculating what two numbers multiply this and combine to be that, you're going to get the wrong answer. There's no getting around it. Okay? If you want to guess and check on this, that's fine. Should we try it? I'll do it both ways. If you want to guess and check, this is a prime number, so you could use guess and check. This hopefully wouldn't be too bad. We've got a 3x and an x. These numbers here have to multiply to be 4 and somehow combine to be negative 1. So what would be the most logical choice to make a 4? What would we typically choose? Probably 2 and 2. But if you put a 2 here and a 2 here, and one of them has to be negative, you got to choose where it goes. And if you choose wrong, you've got to switch it and check that. What if these are the wrong numbers? Which they are, by the way. Then you've got to choose another one. So 2 wouldn't work whether you put the negative in front of the first one or the second one. So then you've got to try and 4. 1 and 4. They need to multiply to be a negative. So you've got to figure out, do I put the negative here or here? That's not going to work, is it? Okay? So there's 4 different ways we've tried it. If I put a 4 here and a 1 here, you still have 2 choices. Do I put the negative here or the negative here? Where do I put it, by the way? Put it on the 4. That's the right factoring, but you'd have to go through potentially 5 different ways of guessing before you got to the right one. Now, if you're really good at that, that's fine. Let's do this just from scratch. I'm going to multiply the 3 and the negative 4 together. That's a negative 12. Are there numbers that multiply to be negative 12 that combine to be negative 1? Negative 4 and positive 3. Negative 4 and positive 3. They multiply to be a negative and they combine to be a negative. So I'm going to write 3x squared minus 4x plus 3x minus 4. Any questions? Okay, look at this. You can tell this is going to factor, can't you? 3 and minus 4, 3 and minus 4. I can take out an x. I'm left with the 3x minus 4. Watch, please. Don't think we've done one like this before. What can I take out of here? You have to take something out if you're going to do this by grouping, so we're going to take out a positive 1. Doesn't change anything at all there. We're left with 3x minus 4. So there's our 3x minus 4. There's our x from the first one. Here's our 1 from the second one. Would I be circling this?
No.
Not unless I left space. What would I forget if I did work over here? Maybe that 6, bring that back. Same answer either way. If you're good at guess and check, great. If you're not, I love this method because it works every single time, the same way. Okay. Anything else? All right. Let's take a quick look at this next one. Take out an x squared. You're left with 14x squared minus 19x minus 3. To me, that does not look like it should factor. How could we check to see if it does?
Multiple of 14.
Okay, 14 times negative 3 is negative 42. I'm looking for numbers that multiply to be negative 42 and combine to be negative 19. And again, there's no harm in this. 1 goes into 42, but you can't make a 19 out of that. 2 goes into 42 21 times. Can you make a 19 out of a 2 and a 21?
Yes.
Yes, I can. I need a negative 19, so which of these two is negative?
21.
21's negative. Now let's double check before we finish this off, because if we screw this up, as easy as it is, we're going to get the wrong answer. Do they multiply to be negative 42? Yep, and do they combine to be negative 19? They do. We're going to get this right. 14x squared plus 2x minus 21x minus 3. Take out 2x. I'm left with a 7x plus 1. Remember, I took everything out. What can I take out of a 21 and a 3? I can take out a 3 and what sign?
Negative.
Always the leading sign. So I'm left with a 7x. Took out the negative and the 3, so that leaves me with a positive. So my answer is 7x plus 1, 2x minus 3 left of the first and the second one. Thank you very much. Love to hear that. Don't forget the x squared, Mr. Laws. Because it's late, it's a Monday, I tend to make, oh wait, there you go. Okay, are there any questions there? Okay, let's take a look at the next one. Would you go ahead and do the next one on your own? Check your answer with your neighbor when you're done. Okay, I'm going to guess and check on this one. So if I were to guess, I would guess that I'd have a 2y and a y. There aren't really many other options, right? This is all positive, so these numbers are probably positive. Just that cuts down on the number of guesses I might have to make. And really, if we're going to make a 9, we're probably going to guess 3 and 3. Now, if we check this, that makes a 2y squared. Those make a 9, so we're in good shape there. At least we got that part right. And then let's check these guys. If I do 2y times this, I get 6y. If I do 3 times this, I get 3y. Is that the right middle term? It is. There's my check. This is the right answer. But if you go through and you say, hey, I'm going to take 2y squared plus 9y plus 9, multiply these two together, that's 18. Are there numbers that multiply to be 18 that combine to be 9? 3 and 6. They multiply to be positive 18, they combine to be positive 9. You can then group these by rewriting the middle term, and it will work. You will get the same answer, guaranteed, either way. Okay? Don't really care, just make sure you get it right. Any questions? Okay. There are a couple more to take a quick look at, and I think I printed this before I caught this mistake. Before we go on, would you just change that? I think it says x minus 3 and then y plus 3. Change that to an x plus 3 if you would. Geez, you're not working ahead, are you? I'm just kidding. Maybe. Okay, let's take a quick look at this one right here. Again, if you look at this and you freak out saying, my gosh, look how many variables there are, just ignore one of them for a minute. Multiply the 9 and the negative 4, negative 36. Let's see if this even has a chance of factoring if it didn't have those in there. I need numbers that multiply to be negative 36 that combine to be positive 5. Multiply to be negative 36, combine to be positive 5. Ari? 9 and negative 4. Let's double check. They multiply to be a negative. Negative 36. They combine to be positive 5. Are we going to get this right? Absolutely. So here's what we're going to do. This is almost easier than some of those easy trinomials. This one right here is 9x squared y squared. We're just blindly writing that down. The middle term gets rewritten. 9xy minus 4xy minus 4. Now, one of the things I like about this trinomial grouping process is that math is one of those things that teaches your brain how to compartmentalize. Okay, I need your attention for just a second. Listen. Okay, math teaches your brain how to compartmentalize. So if your brain hurt trying to rack it and think, how would I factor that? By just looking at these two numbers and coming up with this simple answer right here, this is a problem I could have easily put on the lecture yesterday. It has 4 terms. We normally group the first 2 and the last 2. What do these have in common? A 9, an x, and a y. What's left? An x and a y. What's left?
1.
A positive 1. What do these have in common?
Negative 4.
A negative 4. What's left?
XY plus
An xy. I took out the negative and the 4, so I'm left with a positive 1. And look what I get. xy plus 1, 9xy minus 4. Now, for those of you that love to guess and check and think that you're good at factoring, I can almost guarantee no one in here would guess that this is the right answer the first time. And here's why. What would you guess you'd use to make a 9? 3xy and a 3xy. What would most people guess is going to make a negative 4? A 2 and a 2. One of them would have to be negative, the other one would have to be positive. So if this would, does everybody agree this would be the most common thing to guess just off the bat? And it's not right. So maybe you end up switching these. Maybe you end up trying a 4 and a negative 4 here until you finally switch this to be a 9 and a 1. Okay? So can you see why that trinomial grouping method, even if you're really good at factoring, if you get something like this, it's a good thing to fall back on. A really good thing to fall back on, because correct me if I'm wrong, if I show you this whole page, doing this one really wasn't any more difficult than this one, or any of the other hard trinomials that we did there. Didn't take up any more space either. Okay, any questions? Okay, these last problems on there, I would like you to do those, just so you can remind yourself how we multiply those types of binomials and that there are some patterns there that you should spot. If you spot those patterns, you're going to be in great shape for Monday. So we've got about 10 minutes left.